In this video, I'll be going over the concepts of the common log, natural log, and how to use what we're going to call the change of base formula to calculate some of our logs here. So first off, just making sure that you all understand our new vocabulary, that a logarithm with a base 10 is what's called a common log. So if no base is written, then the base is assumed to be 10 because it's a common log. So like here, it just says log 5. Well, this log of 5 is the same as log base 10 of 5. So again, it's understood to have that base of 10. Now, a logarithm with a base e is what we're going to call a natural log. So again, here, if I have log base e, of x, this is the same as a natural log. So we use the ln to represent natural log, or we could also see this as exponentially. And we'll talk about that, but this is e to the x, where e is kind of like pi, where it's approximately a value here. So it goes on and on and on like an irrational value. So a common log, if I wanted to rewrite this, a common log written exponentially. So again, here, remember, it's got that base of 10 that's understood, the common log. So this is 10 to the x is equal to n. So that's how you see a common log written as an exponential. So then same thing here, even though I just showed you, again, if I have a natural log, right, of n, is equal to x. Again, remember, right, it has a base of e. So this is e to the x is equal to n. So again, keep in mind that this is how we write our common and natural log as an exponential. And we'll get to this when we're talking about the change of base formula. But before we get to that, in order to use the change of base formula, you need to know how to use the calculator to calculate these problems. So here, what you need to make sure is when you find that button and it just says log, it'll open up a parenthesis. So make sure that you close the parentheses when you put that log in. So here I've got, you should have, putting that in the calculator, you'll get 0.699. And I'm just rounding after 3 places. So here, find that ln button. It should be right underneath the log button. So once you find that ln for natural log, just type in the natural log of 2, which is approximately 0.693. Just to practice, go ahead and pause the video and try these 3 on your own. And here the log of 4 is 0.602. Log of 110 is 2.041. And the approximately, right? And the natural log of 5 is 1.609. So again, I was just rounding approximately to that thousandth place, so 3 places. So now the change of base formula. So when we're talking about calculating, so the change of base formula. So what if you have a base other than 10? How do we calculate these? And you could also use the change of base formula when you do have a base of 10. But here, in this case, what if it's different? So now I've got log of A divided by log of B. Because here before, this log is a common log, right, with a base of 10. So you can just put that in the calculator and you get this value here. So here, when it's other than 10, we're going to use that change of base formula. So like, for example, 3 here, notice how it's not just log of 16, right? It's log base 4 of 16. So to calculate this, you would have log of 16 divided by log of 4. So again, make sure that everything enclosing the parentheses. And so here you end up with the value of 2. So log base 4 of 16 is equal to 2. So now go ahead and pause the video and try these 2 U tries. And here you go. So like here, log base 2 of 8, well, that's the same as log of 8 divided by log of 2. which here you end up with the value of 3. Then you try 5. So again, you have log of 343 divided by log of 7, which here you end up with equal to 3. So again, just a reminder, your base is what's always going to go in the bottom, in the denominator, when you're setting up that change of base. So again, that base 2 here is what goes in the bottom, the denominator. So again, just keep that in mind when you're setting up that change of. And so now in these next examples, we'll be talking about how to solve all these different types, not just the change of base. So like in example 4, notice how here we have this log base of 5, so it's other than base 10, and we're looking for the value of a. So we can use the change of base formula here in order to calculate the value of a. So we could set this up as log of 1 over 25 divided by log of 5. So here, when you use the change of base formula, you do end up with that a is equal to -2. And again, that's just practicing putting in the calculator. So go ahead and pause the video and try this. You try 6 on your own. And here you go. So again, notice how here I've got a log other than base 10. So we could use our change of base formula. So I've got log of 625 divided by log of 5. So here, when you have that in the calculator, a ends up being equal to 4. So now notice example 5, we're not going to use change of base because see how here, yes, we've got that log base 8. We're missing the value of a here, but we know that this is equal to 1/3. So now this is going back to making sure you convert this to an exponential. So here I've got my log base 8. So this is 8 to the, well, again, remember, right, our equation's always equal to the exponent. So this is 8 to the 1/3 power, which is equal to a. And so really, you can just put that in the calculator, right? Solving for a. Now, also, this is the same as, remember, if this is a 1/3 power, cubed root of 8. So all the same, a to the 1/3 power or cubed root of 8, and a is equal to 2. So go ahead and pause the video and try this. You try 7 on your own. And here we go. Again, notice how, right? You can't use change of base because we have the log base 3, but we're missing that value of a. So we can convert this to an exponential. So if my base is 3, I have 3 to the 4th power, right? Because our equation, the log, is always equal to the exponent, which is equal to a. So now 3 to the 4th power is 81. So a is equal to 81. Now, example 6, notice how you just have log of a. So now notice we do have a common log because if there's no base, right, it's understood to have a base of 10. So this is now 10 to the 3rd power, right? Because our exponent here, that's what our log is always equal to, is equal to a. So here that means that's just 10 to the 3rd power, where a is equal to 1,000. So go ahead and pause the video and try. You try 8. And here you go. So again, you have a common log, right? Because it's understood to have that base 10 here. So that's 10 to the 7th power, which is equal to a, making your value of a equal to 10 million. So now looking at example 7, notice how here we have a natural log. Well, a natural log has the base of e. So if I could technically now write this also as my exponential, right? Because it's got a base of e here. So this is e to the 5th power, right? Because our equation is always equal to the exponent. That's e to the 5th power, which is equal to a. Now, in your calculator, you do need to now use that function of e. It'll raise it automatically to an exponent, so you need to have e to the 5th power. So look for that e, and usually it's going to be above natural log. So look for the natural log button, and above that you should see e. So make sure to shift to use that value here. And e to the 5th power, I'm going to go ahead and estimate that a is approximately 148.413. So again, make sure here that's just putting in the calculator e to the fifth power. So now go ahead and pause the video and try this lest you try on your own. And here we go. So again, notice we have a natural log. So natural logs always have that base of e. So this is e to the second power, which is equal to a. So again, practicing putting that e to the second power in the calculator, you should have gotten a is approximately 7.389. So now go and pause the video and try these 6 practice problems on your own. And here we go. So in number 1, you should have noticed that you had both values here for the log base 125 of 5. So you could have used the change of base formula here. And so this should have been set up as log of 5 divided by log of 125. And you end up with a is equal to 1/3. Then in number 2, you should have noticed with the natural log, you have the base of e. So you have e to the third power is how you should have set this up to solve for a. And a is approximately 20.086. Now, number 3, you could not use the change of base formula because we're looking now here, notice for the value of a, but you're given the exponent. So this is a base of 3 to the first power is equal to a, which means you should have gotten a is equal to 3. Then here you have a common log with a base of 10. So that is 10 to the fifth power is equal to a, meaning a is equal to 100,000. Then here, again, you cannot use the change of base because you have the base of 5, but you're looking for the value of a. So that's a base of 5 raised to the fourth power, right? Because remember, your equation's equal to the exponent is equal to a. And a is equal to 625. Now here you could have used the change of base formula because you have log base 6 of 1,296. So this is log of 1,296 divided by log of 6. And here you should have gotten that a is equal to 4.